right, cool. I think we're live. Looks like my mic was off. Yeah. So hey, welcome to the stream. We're gonna get started in a little bit here. But if anyone has any questions or stuff in general, feel free to holla at me. Write in stream, chat and whatever. All right, cool. Hey man, yeah, audio's up. Wait, is the audio? Say something if you can hear the audio, or I guess just type it out. Okay, the audio is down. Is the audio still down? Shit. Most important thing to understand about cues. Okay, I actually don't. This one kind of goes over my head a little bit. Right, sweet. Okay, the audio is fine now. Okay, let's see. Drive with the replays. Okay, so it looks like my client just messaged me. He's gonna let me download all the replays. I don't want this here. All right, cool. Perfect. All right, cool beans. Yeah, then we have everything set up, so we should be good to go in a little bit. One way smart developers make bad strategic decisions. Let's see this one. Let's see what she has to say. Small team developers, mid-sized SaaS company, own several services, do some data load transforming, and the service is under increasing load. Generate many times the amount of data the customers do, manage to get that in control. They've increased the data processing throughput, but turns out they're hurt its fairness. Some customers are waiting, so you have a starvation problem. This is the worst kind of problem. The kind of problem where an executive didn't know that a service existed is now requesting daily updates on it. Okay, yeah. A service that's turned off goes full on. So that's basically the last mile problem, or the tail risk problem. Well, however you want to describe it. It's just a service that was not expected to take on heavy load is now taking on heavy load. Who can help with the system? Let people who know the system best. So the team finds a compromise between fairness and throughput. Okay, that's fine. Senior technical lead. How can you make sure this doesn't happen again? We expect N more customers besides customer A. Can't afford to keep learning this incident again. Studies all existing services, map things out. Okay, so yeah, he's finally understanding how the system all works. They create a shared library which can use to queue and process everything. It'll be backed by Kafka, and everyone moves to it. Okay, so setting aside some kind of beautiful unifying solution that solves this problem once and for all. One person working on one service solves work starvation problem. Others can use the solution because they share a library, and if things go wrong in one area, everyone from other teams can lend a hand because it's all the same solution. Yeah. So how did this actually fail? Every service to process data was doing things slightly different. System as a whole, hard to understand from a top-down perspective. Hard time wrapping around how everything worked. Standardizing these things could be solved all at once. Hypothesize standardizing was a considerable effort that solved some problems, but overall it made things work less well. Interesting. Okay, yeah, so it's just an issue of how standardization actually failed. Okay, so it looks like he's seeing like a state. He's citing this book. How is that valuable? Contains random trees. It's illegible. You can't understand. They make different types of trees. Turns out reality is messy. I mean, okay. So what exactly am I reading here? This impoverished ecosystem couldn't support the game animals and medicinal herbs that sustained the surrounding peasant villages and suffered an economic collapse. Okay, yeah. So if you take every single plot of tree land and don't respect its differences, it just ends up failing. Yeah, I mean, that's just a systematic way of approaching things than realizing that you oversimplified and overstandardized. Okay, so then I get it. I want you to clear the way. Seeing like a state go through an example problem from this book's in modern zone. Yeah. Easy to state. All right. So what exactly are you trying to get at here? It's easy to make this mistake if you want to understand how several... All right. I'll get back to this one. This one seems kind of interesting, but he hasn't really... Oh wait, has he embedded with the team, then solved another problem, then solved another problem? Okay, this is basically a top-down versus bottom-up solution. Actually, it's saying that hey, if you just grew the solution from the bottom up instead of a top-down, you wouldn't have missed it. Holy fuck! Literally, just get. Why did you spend so much time talking about nothing? I hate these articles, man. Like literally, just say hey, grow the problem from the bottom up instead of the top-down. You spent like fucking 9 minutes making me read through a bunch of shit just to get to this one point. Why? Just get to the fucking point, man. Alright, whatever. Yo, hello? Hold up, wait. Hello?
Hello.
Hey, what's up?
Doing good. How about you?
Hey, doing good. Yeah, catch me up on everything. How is the homework been for writing things simply, etc., etc.?
Only one word can define, I guess, obsessive. I've been very obsessive to
Good.
be as simple as I can, and be understandable.
Okay, good.
Say, and as you predict, I was like kind of more slow in terms of exercises, but I would say that the point you said to me to work on, in my opinion, is better.
Okay.
So I've been stressing out this part too much.
No,
That's
you
pretty
should be
much it.
overstressed. I'd rather you be overstressed about it than understressed, at least in the
Yeah.
beginning.
No, no, yeah, that's totally good. Yeah.
Okay. So, can I see your practice diary and all the docs that you've done so far?
Uh, I send you on the chat,
Oh,
like
okay.
the the videos. I record to replace in case you want to check. But I guess like the diary,
Mm-hmm.
uh, I mean like the Google Doc.
Mm-hmm.
I copied like all the optimal solutions in a section called My Approach in
Okay.
every like comments and thoughts. If you open there, you will see.
Okay. The practice sheet
Uh,
M3.
uh, yeah, yeah, that is the practice sheet. But also, if you want to follow from the practice diary, it's also there
Okay.
on the column error comment thoughts. Yeah.
Okay. Let's go ahead and put those side by side. So did you get any feedback from people about like your solution, whether or not it's readable or not, and like how many times did you have to revise in general?
Um, I would say that for every question, one thing actually, I
Yes.
didn't have feedback for anybody.
Okay.
Just like me doing what you suggest, like revise like hours later or in the other day.
Okay.
So that's what I was trying to do. And I'd say that for most of the answers, probably to three, like revise, right? Is that the correct word? Like I had to revise 2 times.
Okay.
And but for after every question, I tried to like look one more time, and there's like a word that was not so clear or a term that I just was not was missing something,
Mm-hmm.
and I tried to like do different. So yeah.
Okay. So I'm gonna look at from March 6th onward. Yeah, like your choice of wording is very very um significant,
Mhm,
and it's like, and that's why I keep always saying keep it simple, because if it's
mhm,
simple, it's
mhm.
very difficult to fuck up and
Yeah.
misunderstand. You know, like there's several
Mhm,
times in the past where you misspoke
mhm.
the runtime, and
Uh-huh.
that like we're like oh whoa, and even your friend I remember you said
Yeah,
she
yeah,
got scared too. So be very
yeah.
simple and be very and make
Mhm,
sure that every single word is deliberate.
mhm. Uh-huh.
Okay, so let's see.
And there's only one thing I'd like to say here.
Yep.
Uh, like you said to me, use 10 words or less to be simple.
Yes.
Uh, uh, I'd say that for half of the exercises, I used more.
Okay.
I tried, it's on like the 15 or even a few more, but I was trying to read what I wrote,
Uh huh.
and understanding 10 seconds. Basically, that's the other metric I was trying to use
Uh huh.
in order to write those, yeah, approaches.
Okay. Got it. Okay, so let's start with ones that you felt. Show me the one that you've felt like you had to go back and forth on the most.
Okay, so just a minute. Mm. Oh, I'd say that the yeah, evaluate RPN expression because that was kind of recursive. So I was not so familiar to explain like recursive for a 5-year-old, you know.
Mm-hmm.
So that one I had to like go back more than 3 times, being honest here,
Okay.
because I was not. Yeah, it was kind of different. Was one question that was kind of different.
Mm-hmm.
Um, because I solved in a way that was like more clear to me,
Okay.
different than the book. The book.
Okay.
And let me see.
Let me
Go
open
ahead.
that up first. API use a stack and for different lambda functions. I don't care about the lambda functions for the plus minus to be honest, but it's anything but the recursion, but using the recursion stack instead and for if cases. Okay, so you used a bunch of if
Yeah.
cases, but it's
Mhm.
pretty similar. You iterate through the array backwards. Well, let me actually see what the problem says first. This is
Mhm.
RPM. Which remove duplicates? No, no, no. What do you mean RPM?
It's the name of the expression. Hold up, I'm gonna send you.
Yeah, I don't see it in my book under linked lit. Oh, you put it in stacks and queues. Never mind.
Stacks and queues, yeah. It's
Oh,
like
okay,
the
I got it.
second exercise.
Got it.
Yeah.
So let me open that up. 135. Okay, evaluate. A string is said to be an arithmetic expression in reverse Polish notation if it is a single digit or a sequence of digits prefixed with minus 6. 6, 1, 2, 3, minus 4, 2. Single digit or sequence of digits prefixed with an option. It is of the form A, B. Okay, so a string, if it is a single digit or a sequence of digits, okay, prefixed with an option, or if it is of the form a comma b comma dot, where a and b are RPN expressions. Oh, recursive. Okay, okay, got it.
Yeah, yeah.
So for
From
example,
backwards, yeah.
got it. Okay, the following string satisfies this rule. 1729 satisfies it because it's a sequence of digits prefixed with an option, with an optional minus. So minus is optional. Got it. And then you need to also have a comma b comma dot, where dot is the where a or b could be RPN, and then you have a plus or minus. Okay,
Yeah, yeah.
I see. So let's see. Y3 for x RPN here. A
If you
b.
want me, I can try to explain to you. For
Yeah.
example,
Mm-hmm.
if you will start, imagine that is 3, 4, and plus, right?
Yes.
You do like 4 plus 3, and then go to the other. So you do the result from 3 plus 4, and then times 2, because the following one is times, it's
Oh, I see.
multiplication.
Okay, yeah, you
Yeah, and
group
then
342 as a RPN.
yeah, yeah. But
Okay.
you need to calculate like backwards. That was the only way I see this.
Okay. Yeah, yeah, that was a good explanation, by the way. You notice how the moment you said it, I instantly got it.
Uh-huh.
Yeah, you said just group 3, 4, and plus, and then it's like, oh, yeah, there you go. Okay,
Yeah,
so now I
and
understand.
then you do the operations recursively, kind
Okay,
of like adding up to the following ones.
okay, got it. So
Mhm.
let's see what your solution said. So let's see. I assume that you have it on practice sheet M.
Uh, practice sheet M3 is like there's a 3 after it. Yeah.
There's a 3 after it. What do you mean 3 after it?
No, it's practice sheet M3,
Oh, practice sheet
like the
M3.
third one.
Okay, what page am I
Yeah.
looking for, or did you actually write it out the name of the problem?
Hold up. Yeah, I just wrote the name of the problem, so it's easier to find there.
Perfect. Good. Okay, cool. Our 1 plus 4 equals 15. We'll write a program to take it and return the number that expression evaluates to. Got it. Okay, so you did 1 plus 4.
Yeah, I was trying to discover how to solve this first before writing anything.
Okay, so you're just trying it out.
Yeah, yeah.
And so, okay, so you did this. Why is this 1 plus 14? Oh, okay. Oh, you did 3 plus 4 here, and then 7. Oh, okay,
Yeah.
now I got it. Perfect. Okay,
Yeah.
as long as you can explain this part, you're fine.
Uh-huh.
So if
Uh-huh.
plus, take the n minus 1 recursive call, yeah. So minus on the n, take n minus 1 element, minus recursive, yeah. Good, good. Okay, I instantly understand what you're doing here. You tested it out. Good. First approach, iterate through the array backwards. Then for each selection, select this operation to be calculated with the previous results. Then at the end, backtrack doing the calculations. Okay, yeah, iterate through, and then for each iteration. Okay, I was a little bit so iterating through the array. Okay, you're iterating through the array. Then for each iteration, select its operation to be calculated with the previous results. I would say be a little bit more atomic about this. The only reason I understand this is because I understand what you're trying to do here. This is like a little bit of a red flag, but their saving grace is how simple you made these rules up here. So be more careful about that. Backtrack to calculations.
Can you just tell me like more atomic, like be more succinct? Do you mean or detailed or not so vague?
A little bit. You're a little bit vague on here. So for instance, when you say something like iterate through an array, right? You're gonna go when I think about this, I'm thinking you're iterating through every element piece by piece, right? So index I minus 1, I minus 2, I minus 3. And then for each iteration, so you're saying I minus 1, I minus 2, I minus 3, select its operation to be calculated with the previous result. So you see it like immediately that doesn't work. It's kind of weird because you're telling me to iterate through every single element in the array, but then for each element in the array, select its operation. But then you already have this definition of of where the array effectively gets pretty much split up and recursively called back.
Yeah.
So this is actually this is not a correct explanation at all. It's just like your choice of words here kind of suck. But again, the only saving grace is because you did this. It's like, okay, now I actually understand what you mean. So again, this is like be a little bit more careful about it. So pseudocode traverse the car at an n-2 pace.
Yeah, I was like to go from like two positions at the time. I was trying to say this because in Python you can define like the pace, and I was trying to show this.
Okay, yeah. So you're gonna walk through like you get an operation here, operation here, operation here, and then if it's an operation, compute the n-1 recording selected. Okay, so let me see what you're doing here. Let me see. So
yeah, there's also a case that there is not an operation, so it's a number. So in this case, I'll return the number.
Okay, fine. Let's see what you did here.
Oh, it's I need to do this actually.
So
I did right on the rule set.
Okay, let me compare with the book because something doesn't seem right here. Something doesn't seem quite right.
That was it.
Let's see. Okay, split. Yeah, something's not right here. Okay, I'm curious.
Yeah, the book did like a much more succinct version of what I did, like with lots of lambda functions. Avoid those if
I'm looking at it right now. I'm on the Java version, by the way.
Let me just see how is the Java version. Oh yeah. Oh, the Java version is much more similar to mine, but the Python one, I can send you like a picture.
It doesn't matter. It literally does not matter. If you're focusing on lambda expressions, that's the wrong thing to focus on.
Yeah. Oh, so okay.
You should be focusing on the compactness and readability of the code. So when I see this, traverse the string backwards in an n-2 base. If there's an operation if it's an operation, compute the n-1 element according to the selected operation, and then recursive call. But I don't think that's quite right. I'm pretty sure that's not right because by definition you have a potentially two different RPN numbers, right? So but if you go back to the definition of A, B, and then dot, the dot is the operation, right? But B can be an RPN and A can be an RPN. So why do you assume that compute the n-1 element according to the selected operation? No. You're not guaranteed that that's exactly an integer either. You could
but yeah. Go ahead.
This -2 could easily be like a -2 and then a plus.
But I'm doing like a recursive call, and if you see like for the index -1, minus 1, I do another recursive call to index -2. So I'll be calculating like using the backtracking, you know.
Okay,
So that's
let
what
me double
I was
check
trying to do.
because something seems fishy here. So you have a helper, you have the length of the expression, which is the index you start at, okay, and then the
Yeah.
expression list itself. Fine. So the expression list is whatever you split by commas, okay? And then if the index is numeric, then you return back the element here. Okay,
Yeah, that's
okay,
the base case. Yeah.
fine.
Like
If it's
yeah,
plus,
actually.
then you do the recursive call to the number. Yeah, this is exactly what I have a problem with actually. I'm pretty sure this is what I have a problem with. So let's because it's 2 comma and then let's say I have this. This would still be RPN because this is still a block here. This is a block, right?
Oh, okay. So that case.
This is what I was talking about. Like, why is this right? You know. So this basically tells me that you didn't test very carefully.
I didn't test for this case. Yeah.
Well, yeah. So you basically skip steps. Again. You how do it's kind of the same thing. It's I mean, I didn't even give you another problem.
No, but is this an RPN number? I don't think so.
By definition, RPN should just be a as a comma b comma dot, right?
Yeah.
What actually? Yeah. Why is this? Why actually? Let me try to understand something. Let me see why this is the right issue. Okay. Why does this work? So let's actually take a look. So let's see. RPN a dot b, right? So by definition, this it's either going to be a digit or it's going to be okay, I got it.
Yeah.
So this is going to be a block.
That's not valid.
This block here, and then this must be a block, by definition. So this is a block here. So yeah. You see what I did here?
Okay.
So you take the 3 plus 4, and then you combine that with 2, and then do the x operation. Do that combine that with a 1, and then a plus. So basically, you didn't test the right case. You got caught up in these examples, and just kind of assumed, oh yeah, this is like the way it works. So, yeah. To me, it's very obvious. Like it's a b dot, right? Because it was a recursive definition. So why not just mimic that definition? So it's kind of I'm not sure like why you kind of skipped that. It feels more like you should have been able to see the example and then just realize where you fucked up. It boils down to you not being careful again.
Yeah, man, I just try to mimic like the free lunches as you mentioned, right?
Uh-huh.
So it was my bad. Like I didn't invent like where my code would break. That's a fail of mine. Yeah.
Well, not just that. It's like the examples. They gave you several examples here, and then yeah. I mean the examples, to be fair, like they're limited, but at the same time, you need to be able to consider the definitions that they're giving you. Like really like it's not just the examples. It's also understanding what the hell this means specifically. This one, right? Derivative of the form. It's a recursive definition where the form a, b, and then dot, right? So which means that by definition, when I see these two what's it called things, this is base case. I see this as base case because at the bottom of it, you must be able to have like digits.
Yes.
That's the thing is, but the thing is that this minus 42 is just an integer. So basically, I read this like each cell can be an integer, and then the recursive form a b dot, right? So in theory, by that definition, if I have a b dot, then I can have like a b dot. It uses a b dot, and then like this. You see how easy like that right now? Then this one would just be like consider like these dots could be different.
Yeah, I see.
The recursive definition is already given to you, so you should have easily been able to see this. That's my problem. Like I feel like you hung up on the examples again, where it's like, oh yeah, I solved all the examples that they gave me, I'm good. But notice like all I did was just like take the rules that they gave me, and then just say, hey, well this is a recursive definition, and by its own recursive definition, it's this.
And yeah,
So
this will break.
Yeah, it'll break. So that's you really need to be really careful on these. I'm not sure how to because I'm pretty sure like what's going on is that you just said, oh, I solved all the examples, I'm good. But I feel like there's also something more to it. Did you? What else? Was that the only thing you did, or was there more?
Do you mean like for this exercise?
Yeah. Like, like how else did you test this?
Basically, I just looked to the expressions that the book gave me, and then I try to like walk through it, seeing like a rule set, and yeah, I try to create a code based on that.
Okay.
Like,
but I also.
But I didn't.
Uh-huh.
I didn't like did this same thing as you did. Like, try to create how to say like a very different example. And yeah.
Okay.
That was it.
Okay. So you said that you basically did the same approach as EPI, but I am seeing very clearly this is not anywhere near the same approach. How did you justify that these two were the same? Let me ask that.
Yeah, I assume it wrongfully. Yeah.
Oh,
because
yeah.
I like compare all the operations, and then what was on the stack. So instead of like declaring the stack, I was doing the call stack. Anyways, that was totally wrong.
Yeah. So I don't see any relationship between the recursive definition here and this. So basically, you basically just kind of. I don't think you were really critical at all when you're comparing against the book solution. That's what I'm seeing. Like, when I said that you need to be super serious about this, I mean literally be super serious about this. Like, what is it that what are the steps that you're taking to evaluate the difference between what you did and what the book did, and then ask, how did you get to the conclusion that you and the book did the same thing? Maybe it's a misunderstanding.
Basically, I first read like the steps that they took into the solution.
Okay.
And then I try to understand the code.
Okay.
Like, because it's gonna be simple. And then once I fully understand the code, like based also on the explanation, I try to compare mine if the line of thoughts were closer or like were pretty far from other. And in the times where it's totally different, I try to see where I went in a different path of the book, and therefore I don't repeat the same mistake.
Okay.
So basically, that's the framework to evaluate.
Okay, you did that, but you say that, but to me, it would have been very obvious because where the book went, they just iterated from left to right, and you went for the recursive. You went for like some recursive split what's it called array thing. But then the next question would have been, how could you tell that you could split the array like this? And even then, like I came up with this recursive definition, and I showed you this, and then you showed the examples as well. So to me, it boils down to you just basically went with the book's examples and then just said it was done. That's really all I can see here. And then you just kind of assumed, oh yeah, well I went to a completely different wrong path, and then the book, and I got the same answer as the book, but you didn't.
No.
So it's kind of hard for me to say.
But if you look at like at the beginning of the solution, right? They take like this expression, like 3, 4. No, like in the beginning where they start to write 3, 4 plus 2 times 1 plus. And like looking this, I went in the same direction. You know, like calculate the 3 plus 4, and then go back to the 2, backtrack to 2. So basically, at that time I was going the right direction. But yeah, I evaluate this wrong.
Yeah, 'cause to me, it's yeah. I guess you tried to figure it out, which is good, but then you ended up just like starting recursively, and then to me, it's like the answer is not obvious how you split up the array because like if I'm in your shoes, and let's say I start off like, okay, I figured out how to calculate this. Now let me start backwards and from the operation, and then split the array into the two definitions. To me, now it's like, okay, well, this 2 by 1, right? How do I split this? It's like, okay, well, let me just take the one index, right? But then if you just thought of the recursive definition, you would have immediately would have failed. So even then, like to me, it's just that misunderstanding.
Let me try to explain to you.
Yeah.
I think there's I'm not having the right words to explain.
Okay.
So for example, I even draw like on the below lines like 1 plus 15. You know. So for example, I'm just gonna open this just to try to
Sure.
walk through the same approach that I took. Just a moment. Sheet 3, page, please.
Hello. What?
RPM.
Okay.
Okay. RPM. There we go.
Okay.
Okay, so here I am. I was trying to do something like 1 plus something, like that I didn't calculate yet.
Okay.
And I will go to, okay. Then, okay, 1 I have, because it's like the n minus 1, right? So I will place the 1 here. And then this part is going to be the recursive part. So I'm then going to traverse to like the next operation, that is the multiplication, right?
Okay.
So I'm going to be in the other recursive call. So I know that is 2 times something that I didn't know yet. And then I'll move to the other operation, which is plus.
Okay.
And then in this case, I will hit this is going to be 4 plus something that I don't know. Okay. Then I'll hit like a base case, that is 3.
Okay.
Right? And then I'll backtrack like doing 4 plus 3, then take this result and put it right here, you know, just going back and backtracking.
Okay.
So that was like my walkthrough.
That's fine, but okay, so I see what the problem is. The problem is that you just kind of got done with one example and then just said, oh, it works for this example, it works for all examples, like there's nothing else, and you didn't think of like the general definition that I did.
Yeah, and then I tested this second one, that is like 1 plus minus 2. Okay. And the same thing I said, right? I didn't test for this example of like 2 definitions of RPN expressions.
Yeah, but to me, it's like you just kind of ignored this one fact. That's it. So, and then that threw off the rest of it. So, I'm gonna say that it's not just about like examples. It's about like making sure you've covered your ass on the entire problem statement. So, and again, you need to be much more critical of yourself on this as well. Because even then, this should have tripped. Like, even if you submit this and said, "Okay, I'm done. Let me compare with the book," it's like it's vastly different even. And all you did was just compare it against. I think the way you validated was just like, do I do the same example? But that again, it's So I understand why you thought it was the same, but it seems like there's a pretty big oversight here. I think it's just basically you completely ignoring this rule and you kind of misjudged it from the book. You only use the book on the same exact expression. Okay. But yeah, to me, I also want to say that I understand why you thought the way you did, but I would say if in my position, I try to avoid recursion like the plague, unless it is absolutely obvious. Like, I remember what I talked about before, where it needs to hit you over the head like a 2x4. It's like, this is recursion, dummy. Like, I understand why, but to me, when I'm doing like calculator type problems, I just like reading, you know, A, B, and then operation, A, B, operation, and then combining that. So I understand where the recursion comes from. But to me, it's like, it's not blindingly obvious. So there's a little bit of intuition in there as well. But the main thing here is just this misunderstanding of fact. So
one question.
Yeah.
for me to get better in this
Yes.
is like try to extrapolate the definition of like that he did to me as you did here, right? In this.
To me, it's just read the fucking problem. Make sure you covered your bases.
Because I didn't cover this case, didn't come to my head yet.
Okay. But I mean, like step 2 is the recursive definition, just by because it is the form a b dot, where a b are RPNs. So therefore, if literally just within those like 10 words, I know that a b must also contain a1 b1 and then another dot.
Uh-huh.
So it's literally just reading the problem and making sure you've understood every single detail of the problem. So that's basically the takeaway from this one. Make sure you read the problem. Read it 3 times if you have to, because that takes just one extra minute.
Yeah.
And I'll tell you straight up, I'm the one who fucking hates reading, but I do a lot of it regardless.
Yeah, to guarantee a position in the big company for sure. I'll read like anytime it's needed.
Yeah, so you need to be very, very careful on this. So if I had to, let me open up your sheet here, prep doc. So I'm gonna just say right now, reread the problem 3 times. It's gonna be and make sure you truly understand all the cases it can run into. So that's basically it. I think. Let me see what other problems that you did. Okay, so what's another problem that you want me to look at?
Well, there's like a problem. Just a minute. Because hold up, just a minute, because my dog is like
do you think
doing something that I sorry about that.
Yeah, that's fine.
There's this problem where implement just a minute. There's one problem that that one. Test overlapping lists. No. Actually, test for cyclicity.
This one?
Because, like what EPI, what I understand from the prompt, like from the description of the problem, is that for me to discover if like a linked list have a cyclicity, right?
Uh-huh.
So that the same thing happened with the overlap. That I guess is the following one on line 143.
Okay.
So basically, I understand just to check if like I reread the problem like more than 3 times for those 2.
Okay.
And it's saying like as for cyclicity, if like there's a cycle in the list, right?
Yep.
But at any point, they are asking to after test if there's a cycle, return the start of the cycle.
Yep.
So I just discovered where the cycle was, and that was it. And I just returned the node where I discovered this, and not the right node that is the start of it. So I missed one more operation that should happen.
Yes.
And the same for overlapping. In the overlapping, like what I did is just discover if there was overlapping in the most optimal way, right? But like the answer of the book was to discover all the nodes that have overlap.
Okay.
That was probably something that I would ask for the interviewer, but anyways, it's something that it's not the right result. So I was not happy with those 2.
Yeah. So it sounds like it just boiled down to the exact same thing, where you missed 1 or 2 things in the problem statement, and you just got the wrong thing.
I will open here because that one I'm pretty sure that it's not on the problem statement.
Okay, let's see. I'm looking. So let's look at this first one. The test for cyclicity. Although linked list is supposed to be a sequence of nodes ending in null, it is possible to create a cycle by having a linked list. Blah blah blah. Yeah, referred. Write a program that takes the head of a single list, returns null if there's not a cycle, and the node at the start of the cycle if a cycle is present.
I understand like the cycle being. My definition of start of the cycle was different than like what is right.
Okay, what's your definition?
My definition is where the nodes meet each other. So basically was that. Not like where the cycle like where the cycle link with the list again.
Okay, so
So
you mean from 4? In this example, you have 1, 2, 3, 4, 5, right? So you're saying that your definition was 4, not 2.
just a minute. Oh, there's not the same example. Let me just look on that.
I'm looking at the sheet that.
Yeah. My definition was that the cycle is the 4. You know,
Okay.
the start of the cycle is the 4.
Okay.
But in the real case is like the 2.
Okay.
That was the thing.
Okay,
about
fine.
this problem.
Then all you need to do is just return dot next in the cycle case. So it was a very simple adjustment. The interviewer in this case would have just literally told you, "Hey, yeah, that's not the definition. That's not the head," and then you should be able to make that change. So let me see if you wrote that. Let's see if you wrote that. Save last node. So test 142, right? Your approach was save the last node reference for the first linked list, reverse in place the second node, then compare to the last node. Okay. So I think they did fast slow pointers or something, right? And then you did.
Oh no, hold up, just a minute.
Yeah.
Reverse in place. Oh, sorry. For that one, only for that one, I just copied in the wrong line. Sorry about that.
Okay, you gotta be really careful. No, come on, man. You gotta be careful. I keep saying, be careful about the fucking homework. This is fucking homework.
It's because I was trying to make it better, but I messed it up.
Okay.
Okay, hold up. Simplicity.
Okay, let me see your answer at least.
Yeah, that one. Just a minute.
P2 head dot next, while P1 is not none, P2 is not none.
Yeah, that is the better approach. I just copied, bro. I was trying to make 2 copies of it. And...
What?
Yeah, it's the 2-pointer. It's the 2-pointer thing.
Okay.
Approach.
Yeah. Okay. They just have an X. Do they want you to return the cycle length?
They want me to return the start of the cycle. So in this case, it would be the 2, not the 4 that I returned.
Okay. Yeah. Okay. Here's the thing. When I see your next and that next, these can join at any point in the cycle. That's the thing. So you found cyclicity, but you haven't found the start of it. So when I see this, it's not that your definition was 4 and 2. You know, this goes back to I only tested against this example, and these two could meet anywhere in the cycle. You're not guaranteed that it's before, just because it's one single, one's double. You know, what if I change the list of this, to be like, 9, 12, 52, 71. If I kept adding shit, you're not guaranteed that they'll meet at 4 necessarily. Do you understand?
So my definition, even my wrong definition will be wrong.
Yeah, even your wrong definition is wrong. So again, all I did is just look at this and it's like, hey, wait a minute. You're not, just because one goes forward twice as fast, one goes once as fast. Well, am I really guaranteed that? And all I did was extend the list. And really, you're not, because the longer this thing goes, the more further ahead the fast pointer goes, right? So you're not guaranteed that it's going to be this the number 4 at all. So you didn't consider like what can fucking go wrong. And I don't know. Maybe it's just my instinct, but to me it's very obvious. Like, oh well, if I assume that, is there a condition that it could not happen in? And to me, all I do is just like add more. So my question to you is like, why did this not come into your head? Was it because you're fixated on the example again?
It's because I did this in the past, and I just rely on like what I did in the past, actually.
Okay, yeah, okay. Again, like, I did this in the past. Well, turns out you screwed up in the past too. So,
for sure,
I would rather you just like try starting over and just like try growing from the ground up. So, Like everything you did before our coaching session, I would rather you just fucking ignore that and just try proving that the answer actually works. So, like, so this just this is another exercise of, hey, what can go wrong, and all I did was a very simple test, right? So this is so
I
this
feel
is,
like
this is just multiple.
I feel like
Go ahead.
yeah, that's something like it's like that only one thing would solve like two of the problems I showed you.
It's just that consideration of what can go wrong. So, you know, it's like rereading the problem. And did my assumption actually come true? It's like when you told me, oh, it's the element before the list. And I'm just like, really? Well, what happens if I change the problem, change the example? I just made one little change to the example, and then suddenly your definition completely collapsed. So all I do is like tweak the problem. So so if you just like try another example outside of the book, or at least try to understand what complete test coverage is.
Yeah, because no. Anyways, yeah, you're right.
Huh.
I'm just seeing like this go wrong because I just want to see.
Yeah. So you basically it just boils down to, hey, you don't understand what it means to cover your ass completely, like for test coverage. I think I have a video on that actually for what is test coverage, and I just break it down by cases.
You have like the priorities thing, like to make sure to safeguard all the priorities.
Not just that, it's also like being able to break it down by cases, right? So in this particular situation, what I see is, okay, I have a fast pointer and slow pointer, right? And then at some point they're gonna meet up, right? But am I guaranteed? The next question is, okay, can I make a statement about where they meet up? At that point, like, it's not immediately obvious in my head. So I'm just going to try, but I'm leaning towards no, just because, like, oh, this can run for a very long time, right? So these can meet up anywhere in the cycle. So I need to be able to cover when, like, the next part of my algorithm needs to be, okay, now that I've detected the cycle, how do I determine, where the length of the cycle, where the head is? Because it could be anywhere at that point. And so now I need to be able to say, okay, what happens if I meet at the beginning of the cycle, somewhere in the middle, and then at the end? You know, that would be my best test coverage after that. So you see, like, how I just literally just ask myself, is this really it? You know, and I don't take the examples for face value. The examples are just there to help you understand the problem. They're not the end all be all.
Yes.
So,
and you then okay. That's not guaranteed that they're gonna meet. So let me just see something, so I can discover the start of the cycle.
Yeah. So in other words, when you come up with a solution, is this really true? You know, you need to be like skeptical. It's like, hey, this worked, but did I cover everything? Did I cover my ass in all situations?
Yeah.
So, and part of that is being able to break down the cases. What's up?
No, yeah, I just remember one thing here, just to put in perspective. There's like, I just said that I rely on what I did in the past, right? It's because, like, for this specific question on grokking, it was saying that there's I'm just explaining what I remember. There's an algorithm, I think it's Floyd something, I don't remember exactly the name, that it's guaranteed that they're gonna meet, you know? So I just did here, for this example on paper, and they will meet on 4, you know? So because of that, so maybe I should be able to say that, right? Just to, that it's guaranteed that they're gonna meet at some point.
At some point.
Is like, but in this case, it's gonna be in the end of the cycle, not in the beginning of the cycle. So that's the difference.
Okay, but even then, like, you say they can meet at the end of the cycle, but to me, when I see that, I'm just like, really? That's all I said. Really? Like, let me try it out on a little bit longer thing. Let's see what's up, right?
Yeah, I did this actually now. That is not the time to do it. Yeah, but and I see that they meet in the end of the cycle.
Yeah.
Yeah.
Okay. We might not get a chance to go to the replays themselves, but I'm seeing a lot of significant problems. Let's look at one other thing you did, and I'm gonna give you a new homework. Okay. So what's one that you feel like you did really well on, and that you didn't make this like little mistake of, oh, I didn't check the examples.
Just a minute. I think the compute binary trees nodes in order, increasing depth. So, like to traverse level by level, and yeah, I did like
Okay.
I iterate in the tree in a level by level traversal using a stack.
Okay.
Actually, a queue. And then yeah, I just created like the answer. So that was
Which
kind
row is this?
145.
Binary tree in order of increasing depth. So let's see what you wrote. Your EPI solution was more succinct than yours because they are iterating inside a list, but the solution was the same.
Yeah.
Okay, your approach: iterate in the tree with a level by level traversal. For each level, store its nodes and group it by level in the final output. Let me actually see what the problem says, and then maybe that'll make more sense.
The problem is on Grokking too, like but with a different name.
Okay, cool. Okay, binary trees are formally drawn in chapter 10, each blah blah blah. Given a binary tree, return an array, so consisting of the keys.
Mm-hmm.
So you mean of the same level? Okay, so for example, keys should appear in the order of the corresponding depths, breaking ties from left to right. So for example, you should return 3, 1, 4. 6. Okay, let me actually see your sheet. Okay, I think I understand what it's trying to ask. So let's see what your sheet is. Compute. So compute binary tree in order of increasing depth. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, cool. Yep. First, iterate through the tree using a pre-order traversal. For each node, store its value and depth. Then use the values recorded to create in a node level by level.
Yeah, that was a naive approach.
Okay. My question now would be, well, why didn't you think about like breadth first search? Why was it pre-order?
No, I was just trying to create a solution to be in the naive approach. So
Okay.
that was the other solution I had in mind.
Okay.
Fantastic.
I would not have gone for, when I see levels and depth, I'm thinking breadth first search automatically. That's
I think the same, but just to like show like a more naive approach, you just put it. Yeah.
Okay, but I would say like in the future you don't need, if it's like that naive and that wrong, that's obviously wrong. That it's like, you already have a better one, then probably it's fine to go to a little bit better one. Because obviously I'm like not like literally the depth first search in any traversal for me, I would never submit that as my initial solution as well, because like the reason why we do the naive to optimal is so that way we can build on top of an existing solution, so that way we can get a better solution that is not obvious, right? But if you have two choices that are, one is more likely than the other and they're both equally simple and easy to not fuck up, then I'm going to go with the one that's more likely to be better, right?
Okay, that makes sense.
It's just based on the level of complexity, and there's a sense to it. It's like if it's very easy to fuck up and very very difficult, then maybe not go for that first. But BFS, DFS, those two choices should basically be, those are your building blocks, right? Those are your patterns, and so you can pretty much go with either one. So I'm just gonna ignore this one.
Basically, I was trying to do a breadth first search using a depth first search. Yeah.
Yeah. So I literally would never do that ever. I think I did that in my video just to prove that, hey, this is something that you should do in practice, just as an exercise. But you should, but like once you know the distinction, this should never happen ever again.
Okay. I'll consider.
Yeah, like literally, because I made that exact same mistake before, but like because I made that mistake, it's burned into my mind, and I can still remember that mistake.
Okay.
And it should be the same way for you. Any mistake that you make, burn that into your mind so you never ever make that mistake ever again. That's how ruthless you should be. You should literally be trying to kick yourself in the fucking ass if that ever happens. Like, I made this mistake, and I was like, fuck, like I'll literally scream like obscenities.
I do exactly the same thing. My mom just say like, "Are you crazy? Why are you doing this?" And I said, "It's my life in game, you know." So
it needs to be. So you need to be that crazy about it. So okay.
Yeah.
Anyway, DQ item 1 visit. Okay, so you did a stack trace for this. Fine. Your queue is now 3, 5, 6.
It took too much. Yeah, it took too much long time. Because I did like the stack trace for the walkthrough, and then later from the example, I was trying to safeguard all the ways.
Okay, but then my question. Okay, so you have a queue, 2, 3 results.
Yeah,
How do you keep track of the levels?
that's-
Because the queue just ends up how do you keep track of the levels? Actually, I'm curious. Oh, I see.
Yeah, I was basically measuring the size of my level.
Okay, I see.
Yeah.
So okay, so let me see your better approach. Let me see your wording here. Too much space being allocated. There's 2 traversals, right? Better approach. Iterate in the tree with a level by level traversal. For each level, store its nodes in the respective list for the level. In the end, have them group. Okay, yeah. So you're basically doing depth first search by elements, and then for each element, you just pile them into the queue, and then change the level that you're at. That's fine.
Yeah.
Okay, I think okay. So 0 while queue is not empty. Take the size of the queue set as the level set. Really?
Yeah.
What?
Yeah, just so I can know what is the until what node I should to dequeue from the queue, if you understand what I mean. Like on this breadth first search.
Oh, you mean you're gonna the number of times you iterate through the
Yeah, on the queue.
Okay,
Yeah.
fine.
Yeah, so for that reason I need to know like the level, so I can differentiate the level by level.
I see. Okay, fine. Queue set is okay for each child. So you create a new level. Okay, for this new list for each child. I would say be careful when you're saying this because when you say new level, it gets kind of weird because the level just means what do you mean new level? It should just be an increment because you go from level 1, level 2, level 3, level 4, right?
So if I put new list level for a new level, what do you recommend?
So I would probably say create a new list to represent the level, but I understand it's just be a little bit more atomic about it. Because again, think of it from my perspective. When I know what the problem is asking, but I've never really looked at it. It's been a while, so consider me basically completely new to the problem. So okay. For each child in the current level size. Don't you mean the current? I mean it's the current level, not level size. But DQ the queue appended to the respective level. So the list, respective list, in queue left child if not null, in queue right child if not null. Sure. Append level create list. Okay, I see. So for every child in the range, I would say in the range from 0 to level size. Because that's well, I guess every for number DQ, or I guess I should say for in the range, like DQ for every child in the range from 0 level size, or say DQ every child in the range counter, something like this, because that way I want it to say in some way that hey, I'm only gonna remove this number of elements. There needs to be some way to convey that.
Okay. To be as clear as possible, yeah.
Yeah, be a little bit more clear about that, but it's fine. It's not the end of the world. This definitely needs some work, but it's a little bit better than what I saw last time. Mm-hmm. So, okay, let's see what the book says. Yeah. So basically, what they do is they empty out the they empty it out, empty out the current nodes and queue, and then they add it to the next depth node, and then they do the assignment operation.
Hold up. The solution is totally different than mine.
Yep.
Let me show you. Can I send you?
I'm looking at the solution right now, actually, for the book.
No, because the solution, of course, the ideas are the same, but the solution in Python, they make use of iterate into a list, which I think in Java you cannot do.
Sure. Send that to me.
I will actually. Can I send you on Discord?
Sure, and I'll just open it up.
Hold up. There we go. Yeah. That was the book solution, and then there's the base case of it.
Okay, let's see.
It's on the other page, but that's the main part.
Okay, so let me open that up.
I have one question about like those solutions.
What's up?
Sometimes they go very like how I'd say like very small solutions, you know. So
Uh-huh.
and I cannot reproduce the same way. So do you think don't focus on it now? Like because it's much more succinct than mine.
Yeah, this is way too esoteric for me. For me, like I don't. I mean, Python lets you do some pretty creative things, but I don't want it to be like super esoteric that it's like. I mean, like maybe this is like okay for Python programmers, but I'm not a Python programmer. That's why I like the Java one. But the overall thing, when I look at this, it's basically the same thing. It just says it's dumping all the current depth nodes, and then it's gonna
Yeah.
append all the elements in the current depth, and then like the current depth node is just going to be repopulating back into it, so it's
Yeah, yeah.
fine. But it's basically the same idea as what Java as the Java version.
Yeah, yeah.
It's not too dissimilar, but they just don't use a counter. So I
Yeah.
would say, I think at this point I would say why I'm using a counter. But then is there a way I can think about this without having to use a counter? I mean, I think like based on what you said, the answer is correct. But let's see. So level length is Q. Pop left. Level dot append. Level dot append. Q. I still think your answer works though. That's the thing. Results append. Level dot copy. Yeah. Okay. Okay. So actually, okay. This is actually a good discussion point now. Your answer does work, but I want to ask you, what do you think? Why do you think the book doesn't opt for a counter? Let me ask you that.
Uh, no, can you ask this again? Sorry, I didn't catch.
So you said the difference between your answer, and the book's answer is is basically the fact that you use a counter and they don't. Why might the book not want to use a counter?
Okay, just a minute. Current depth. Um, like the first thought is to be more like be more succinct with the code, like
Okay, but
and
okay.
uh,
Go ahead, keep going.
and oh, I see. I guess no, it's a guess. I'm not gonna commit myself with it.
Okay.
Like I maybe if the tree is not fully balanced, like
Not really. No.
mm, balanced. Um, since each node is enqueued and dequeued exactly once, just yeah.
Wait, let me know if you give up. It's because it's not super obvious, but I want you to definitely give it a try at thinking about it.
Okay.
Yeah. So I guess in the interest of time, since we're almost out, so let me paste the solution here. God, it's crap. Okay, okay. So let me actually. Can I highlight this actually? Oh God, I wish there was a way for me to copy.
Oh, I
paste it.
think if you do Control Shift V, I think that works.
Okay, let me see.
Not. No, no.
Oh, that
not
works. Yeah,
really.
you're good. Thanks for that. That actually works. Okay. So
Yeah.
let me show you. Maybe it's easier if I just show you in colors, actually. So let's say this is a current depth node, right? So let me... And I'm going to illustrate this point literally right now. So look at the number of times current depth node is used. And the current depth node poll. And then the next depth node here. And then I think, yeah, that's pretty much it. Those are the only really important parts, I think. Then you have like a result here. Let's use blue, some horrid color. And then this level, right? This level. So this level, this level, this level, and then current depth. Okay. So you see the color coordination on this, right? So basically results, each one basically only has one job and one job only. So in this case, let's look at like next depth node. Where is it? Okay, cool, perfect. Let me highlight this thing holding yellow. It'll make a little bit more sense. So you can see here, like now that I've color coded this, what do you notice? You can see that each one possesses a individual role, right? Let's take result. Result, all it is just carrying the result, returning it at the end, right? For levels just carries in, hey, this is what I currently have, and my job is to add whatever's at this level into the result and add that to the end, right? All next step node does is, hey, I'm just gonna take the next step and then attach it to current. And then current is just like, hey, this is the main thing I run into. So you can see here, like, there's very clear separation of responsibilities. And each one does one thing and one thing only. And you can see like how each of these like play into one another, right? So let's like do the same exercise with your counter. So counter's yellow. Counter's yellow. Level length. Level length. And then so you have your Q here. Oh, let me make this. Q append. Blah blah blah. And then current level here. Let's create the screen. Wait, where's current? Oh, current level dot copy. Wait, hold up. Where's the other current level? Shouldn't this be? This is current level. This should be current level, right? Yeah. Where's the current level? The only I see current level here.
Oh, I think that's a typo.
Yeah. No, you gotta be. Careful
that's a typo.
You gotta be careful about this shit, man. So basically, what's the point of me doing this, right? The point is that notice like the distribution of colors here. Notice the distribution of colors here. Basically, what I'm trying to show you is that, yeah, your code is, like, probably okay, but the thing is that you're basically you have two variables to express one idea. Whereas here, like, the results, like, even though we're using, like, pretty much the same number of colors, the difference is that you're using two variables to express the same thing. And I will tell you, counters like this are notorious for fucking up. Like, in fact, let's look at the, like, it's just very, very difficult to be very, very atomic about it. That's basically what I'm trying to say here. And even though, like, in fact, actually, you know what? Actually, you don't use the same number of colors, do you? You actually use this. So basically, it's a small thing, and I wouldn't worry too much about it. But what I want to show you here is that it's very, very difficult to basically manage colors and manage what's called not colors but counters. And so having like more variables flying around just means more shit that you need to manage. And I don't expect you to understand this. But this is like a more advanced concept once you get to like proper planning for code, is that you want to reduce the amount of shit that you have to basically manage. And counters is one very easy way that if it's not disposable, like, you know, for like int I equals 0, I less than x, then we don't care about it. I would never do this unless I was doing like for I equals 0. I would actually just replace it with a for loop, but even then I'd be very careful. Because it's not, because in general, the convention is that I just use I to iterate through array indexes. And again, like what you're doing is not necessarily wrong. It's just another variable that I have to worry about. So just keep that in mind. This part of code is like, what is the minimum number of variables I need while still making sense? You know, like let me go back to here, right? The result has one job and one job only. Just carry all the results. This level has one job and one job only. Carry all the data from this level, right? And Q just means the current thing I'm iterating through. And then the next node just means, hey, this is the next queue that I am going to be dealing with. And all I do is just attack. You see how each piece just plays independently of one another, essentially? And just feeds into the next? And
Just one row for each.
exactly. And what you did was kind of like almost like meld them a little bit. Not that bad. Don't get me wrong. I've seen worse. But
Okay.
it's not like very clear responsibilities. It's like kind of like how each one kind of feeds into like it just ends up looking like a huge spider web where everything's connected to one another in your thing. It's kind of, I'm not sure if this makes sense, but hopefully you kind of see like how when this is structured, they just each one feeds into another, whereas you just kind of have like this one big ball.
Yeah.
So I would say try to like emulate this idea of each piece feeds into another piece and has very clear defined responsibilities in each step of your algorithm.
Even though I have to use more variables.
I would say like again, let's if we color code it, and you can color code where we use each variable. I would say argue that this is a little bit easier to read. I mean, even though you might use like more I would say actually, don't you use more variables here? Maybe not.
No, I mean because like some solutions of API, I saw the same concept being repeated.
Uh-huh.
You know, so like what I think to myself, well, maybe I'm like how to say, I'm like putting a lot of work in like a lot of variables, like more than one row per variable. The same thing as you said. And I was just thinking to myself, well, maybe I should try to do things more in the API way, you know? Like, to be more, each thing play each role.
Oh.
Yeah.
Yeah, you should be, your goal is to get your answers and your thought pattern to get to copy what EPI does, and eventually your answer should look like EPI. That's the whole point of this. It's not just an answer key that says, oh yeah, this is like what I did, difference, blah blah blah, and then you just never you just say, hey, that's just the answer, and I move on. No. The goal here is to really clone EPI's thinking. That's the whole point of this.
Yeah.
So, we're over time, but what I want you to do is really go back over this entire, go back over your homework, and you know how we say, hey, there's a lot of examples that you didn't think of. There's a lot of test cases that you didn't think of. I want you to go back over your homework and make sure that you understand and have tested every single thing. And if your answer comes out to be different than EPI, I want you to really try to redo the problem so that way you get the same answer as EPI. Make sure that your that your solution is the code should look very similar, if not exactly the same. So just go by your practice diary. Don't, like the ones that you said, hey, I fucked up, I didn't get the same answer. Go back over and try to clone EPI.
Even reading the solution, like after reading the solution.
I would say don't look at the solution. Just go by your practice diary and then look at the problems that you did. And then just say, hey, I fucked up. I didn't get the EPI solution. Let me try redoing this problem so that way I get the EPI solution.
Okay, I will do that.
Okay. At this point, I'm thinking that, okay, so right now there is two factors. One, you need to be much more careful about the example. But the way I see it is that you've been kind of like saying, oh, yeah, there's a difference, and I move on. But right now, I'm going to be very strict with you. You need to clone EPI's way of thinking. So literally, you should be trying to get the exact same code that EPI does. I'm going to be super strict on this because I keep seeing you just like kind of flake off on this. So get the EPI solution and whatever it takes to get the EPI solution.
Okay.
All right.
Okay.
Any final questions?
No, I think I'm just gonna like keep in the same pace, like trying to be as perfect as I can, like trying to approach the same approach as EPI, I just said. So I think just in case I ran out of exercise, do you recommend like just another chapter?
I recommend you redo all the stuff.
Redo some other chapter. I don't know.
Redo like your old chapters and get to the EPI solution. Don't just go, oh yeah, my solution's the same, yeah, because obviously that's not working. So what I need you to do is really make sure you get the EPI solution.
Okay, and just one very quick question about like the like explaining. Do you think what should I get better in terms of it? It's okay or
it's getting better, but you need more. You need to know what your details you're missing, what details you're not, what part's clear, what part is not clear. In fact, look back over your solution and make sure that hey, it still makes sense to you. If it doesn't, then obviously you fucked up. And then you need to really make sure, okay, what is the principle that's going to allow me to like not make this messy again. So let's go. Let's take the thing I criticized, right? Where is it? They create the new level, right? To me, it doesn't make sense. Like, it's like, do you mean create? But if you mean create a new list to hold X, like to hold all the elements at the current level. That makes more sense. So
sure.
The question is, okay, well, how do I make this more clear in the future? Well, I need to say what the data structure is. I would say what the data structure is and what it's used for.
Gotcha.
So it's like being able to extrapolate those principles and say, hey, yeah, this is what happened, and then this is how I'm going to fix it in general, not just for that one problem. Like, okay, if I notice that I have this like tendency to like mess up and make this thing not clear, like for this line, right? Like, well, what are the commonalities between all my mistakes? And I would say it's your description of the data structure and why you're using it. So that's one thing you could fix.
Okay. Okay then. Okay, that's it.
Okay. All right.
Thank you very much, man.
All right, for sure, man. And then I'll talk to you Saturday. Oh, before I go, once you're done with this, and I want you to re-record for Saturday, because I think at this point mostly we're just gonna be going over your mistakes more than actually doing your doing new problems.
Do you mean re-record what?
So the thing that you sent me today, right? You have a Google Drive, right?
Yeah.
Re-record. I want you to redo this, and then you'll probably notice like a few different changes, right? In the way you approach problems. I want you to redo some of the problems and record those. We'll go over those on Saturday.
Okay, but like from all of the past weeks, right? Just to see like the differences.
Yes.
Okay, gotcha.
Okay, if that's the case, then I'll let you go.
Okay, man. Have a good night. Bye.
Bye-bye. All right, cool. That was it. Still a lot of things to do. Yeah, still, I guess we're still being really lax about the EPI stuff. I think maybe I should have been more strict about it and say, yeah, we're cloning EPI. This is, let me write that note for me. Okay. So I'm going to leave that note for myself as to how to improve in the future. But, okay. Is there any questions from the chat? Let's see what you guys wrote. Bob says, it's not immediately obvious how to implement this recursive solution. Correct. Yeah, that's why I said just do it iteratively. It's not, let's see, does EPI use patterns that Grok teaches? Yep, you just saw one. Fast flow pointer. I think you could do this with GFS with recursive function with param level. Yeah, if you're talking about the RPN or whatever problem, the Polish number or calculator, to me, like, I model that as a calculator problem. And for a calculator problem, I usually just see, there's two ways to see it, like tree and iterating, right? But they already give you a recursive definition, so I understand. But then it's like, well, how do I block them together? That's the part I don't get, you know? And that's why, like, recursive could work. Oh, no, it's just like, it's not obvious to me. Recursive, just trying it iteratively and simply is a lot easier than trying to divvy up an array in some arbitrary manner, because by definition, like, each block could be of arbitrary length. So it's not obvious to me how to split up the array. So that's why I would not have gone with a recursive solution to begin with. Anyway, so I guess that is, for level order traversal. Yeah, you could do DFS with recursive function with param level. Yeah, you probably could. But again, it's just like balance of probability. Depth first search versus breadth first search. And again, like I would have just immediately jumped to breadth first search just based on ease of getting the answer. I'm not saying that you can't get the answer with DFS. I'm not saying you can't get the answer with DFS, but what I'm saying is that you're more likely to get the answer with BFS because BFS is more often associated with levels. So I guess to do the Polish notation problem. So RPN expressions, right? So if you saw here, basically the idea is to treat this like a calculator, right? That's basically what they're trying to say here. It's like 3, 4. I take 3, 4, and then do a plus operation on that, and then the result of that I multiply by 2, and the result of that I add with 1. That's basically what the Polish notation problem is asking. And so the notation here just has a rule that says, hey, well, it takes the form A, B, O, where A and B can also be R, B, N. So this is where, oh yeah, well, what happens if I actually have that? Because remember, the base case can be, it could be a digit. So A could be like 20, negative 50, whatever, right? B could be that, or it could just be another recursive definition. So in other words, these are arbitrary length because of the recursive definition of it. You're not set on the length of this at all. So what made me recommend Relentless book for L3 in my levels stream? Is it mostly because of the work ethic and mindset teachings? Yeah, basically. So let me actually get the book out first. So kind of one of the problems that I saw with like junior level engineers is that they don't get it. The point of let me see if I can simplify this explanation. Hold up. Let me put on something for you guys to watch while I talk about this, because I think it's a pretty interesting discussion. Give me a sec. This might take a while. So the reason why I make people read Relentless is because I think that it's really easy for people who get straight out of college and haven't done really much with their life to just, say, oh yeah, I got six-figure job because I deserve a six-figure job because I worked really hard in college and now I got life set and I am I have no reason to improve because the money that I make is like so good and it will last me for the rest of my life. So it's much easier to self-sabotage like that when you're when you've like basically got like very little life experience. I think there's only a few people who really get to understand that, and these are people who have like accomplished something with their life at the very, very highest level and really understand what it takes to stay in the game. Because the reason why I say this is because tech moves fast, right? There's a reason why when you look at like the average age of engineers, they tend to be very small. The first reason is that the best ones get paid so much that they can afford to retire early. The second one is that they just end up becoming managers because they can't cut it. And then there's like some people who can become managers because they actually deserve to, or they want to, and it's not like they can't do it for lack of trying. But the point is that if you want to progress in your career and stay relevant and not just like be forced to become a manager or just like quit even or make a career pivot, then you basically need to be able to keep pace with the current changes of the tech industry and to constantly be learning how things work. Because the fact of the matter is that there's always going to be someone else who is ready to take your job in any industry, right? But more so in tech because tech moves fast, right? The tech stacks of 10 years ago when we were using like PHP and shit, those are gone. Those are gone. Like you being a PHP developer doesn't mean shit anymore. And so you always need to be learning new things, learning how to be a better engineer, learning how to be absolutely better at what you do every single day. And this is where like Relentless comes in because it basically is the guide on how to really have that mentality of how to constantly solve better problems, to constantly improve, to basically become worth more as a developer. And this applies no matter where you are in your career. There's always something you can do faster and better. And basically the reason why I make you do this is so that way you adopt the right mindset, you think about things the right way, and then and therefore you get the right work ethic. So yeah, that's a long-winded way of me saying, hey, yeah, make sure you have the right fucking work ethic. Make sure that you're constantly like improving, because honestly, you can coast by and get to an L5 level without even fucking trying. But I don't want to hear you fucking say, oh yeah, I was in the industry for 8 years. Why am I not being paid six-figure salary? I deserve a fucking Google job. The fact of the matter is that you probably don't. If you can't even be bothered to learn how things work or deep dive into things or really want to improve as an engineer. Because keep in mind, to work at FANG, you have to be top 20% of engineers. That's not difficult. That's like trying to get into like UC Davis or some shit. Anyway, a lot of people can do it if they just try, right? But if you consider it your own birthright to work at like a six-figure job just simply because you graduated college, I'm sorry, buddy, the world does not fucking work like that. You don't like the people who get into the NBA and just say and shake hands with the commissioner and just say, hey, yeah, I got it made. I deserve my birthright to win a championship. Sorry, no, that doesn't fucking work that way. Like, you still got to work really hard. It's just the beginning of your career. So that's why I make people look at Relentless, because effectively, when you see people being paid six figures, the only other job that can possibly be paying that much is like finance or sports athletes, right? And the principles don't really change between sports athletes and like the fucking and like and software engineering. Really, when you think about it, because what's the average career length of someone in the NBA, right? Like it's like 3 years. Injuries happen all the fucking time. Now imagine if you did have the injuries, like random freak, like knee surgeries, torn Achilles, whatever. You could expand that out to 8 years, right? But that's funny enough. That's already pretty much the life cycle or job tenure of a software engineer before they decide to become a manager or fuck off and do something else. So when you really look at it from that lens, it's basically these concepts and these attitudes transfer over. Like people in the NBA, you can't cut it, you can't shoot anymore. We're gonna replace you with someone else up and coming. Take better and give him your salary, or perhaps he can perform better than you. Like give him a year on the team, he'll probably outshoot you or some shit. And at that point, you try to go become a coach. So it's just more or less the exact same shit. So it's really to get you to realize this is your fucking life. This is 8 years of your life, or 15 years of your life, however long you want your career to be. But at the end of the day, like you should really have that really strong work ethic and really know what to focus on. It's not enough that you crank out code like a madman. It's also that you need to be able to be the best. And when it comes down to it, in your everyday life, you'll find pretty much the exact same thing. If you're not getting better at learning, or doing, and being more efficient at producing your work or understanding more of the code base, you're gonna get replaced. That's just the reality, man. So it's just like get that work ethic in you, and just like you don't enjoy as your birthright a 6-figure salary just because you graduated from a college with a CS degree. Sorry. Yeah, it's not your fucking birthright to work at Fang. Like some people luck in, but it's like when you really think about it, it's like how much experience do you need to have in order to really get there, and like how long? And like let me ask this: everyone who is on YouTube, who is doing like the YouTube game, like I want to become an influencer and whatever, look at their LinkedIn resume. How long were they at Fang for? How long were they an engineer for? Did they have some kind of meaningful impact? And are they qualified to give you long-term advice? You look at it from that lens, and in a vacuum, minus their fucking clout or whatever they got going. How many of them really know what they're talking about? That's all I'm asking. It's like, in retrospect, it's like, would you take financial advice from someone who made, like, say, 40% in the stock market in the last 18 months to tell you how the fuck to invest your life savings? Huh? I've only been a broker for 18 months, but let me tell you how to gamble on meme stocks so that way you can retire early. Doesn't sound good, right? Like, that's fucking absurd. So why the heck would we do this for CS careers? Hey, I worked at Fang for 18 months. Let me tell you how to become a great engineer for the rest of your life. Huh? No, it doesn't fucking make sense. So, I mean, this is just me fucking hating on influencer culture, I guess. And there's plenty of people who hate on that, like not just for CS but for finance as well. And my problem is it's just ethically wrong to give career advice like that and to be so irresponsible. Like it hurts people in the industry too. It's like the reason why we tolerate it is because the code bases that we work on are so well developed and so well architected by people who really give a shit in order to put people who don't give a shit in a box. And so that way, the people who don't give a shit can still contribute to the company, to the bottom line, and still do so in a meaningful way without, destroying everybody else. And, it's like, you gotta make a compromise with reality at some point, right? Where you need to hire people, but you can't let the people who you may mistakenly hire destroy everything that you're working on. So that's kind of like the way, that's why the architecture exists the way it is. And so it kind of feeds into this whole narrative, or at least idea in the culture, that it's super easy to work at Fang, you rest and vest, but that's only because when you get in, the code base has already been figured out for you. So it's like it just encourages that attitude, ironically. But so my point here is that if you just spend 10 minutes thinking about like why things are the way they are, you'll understand how we got to this point here and why it's so easy for people to become software engineers. And once you understand that, you understand how much like people before us have sacrificed and thought in order to get us here. And having that appreciation is like really, really critical if you ever want to like progress through your career. So I mean, I know I'm kind of ranting here, but it's like without that appreciation, you just end up getting replaced. Because again, it's a double-edged sword. Because of how easy it is to contribute to a code base that is well mature and very easy to understand, it's like, well, why can't someone who's 5 years younger than you, who just graduated and it's going to work for half your paycheck, why can't he just do the exact same thing? So that's my problem. It's like, why do people think that we have this to begin with? Why are we here today? How did we get to this point? You know? So it just kind of like pisses me off that people just think of it like, oh, I made it. I made it. Now I can do whatever the hell I want and not give a fuck. So anyway, so I guess that's if there's are there any other questions here? I know I kind of went on a long rant but it's more so just a kind of like me spilling my random thoughts out here. If not, then I guess I guess that's kind of like the end of the stream then. Thank you all for watching. We will be having another stream on Saturday, where hopefully he does better. He's able to progress a little bit more through the problems and not really make those like terrible mistakes of not looking at the problem premises and examples. So that will be at 11 a.m. Pacific Standard Time on Saturday. So with that, hope you guys enjoyed that. I'll see you next time and have a good night. Thank you all for watching.